is a substance that releases hydrogen in water. Acid is a substance that releases hydrogen in water. Okay, so based on Arrhenius theory, if anything actually dissociates in water and releases hydrogen ions, we call them acid. Hydrochloric acid turns into H plus, Cl minus. Nitric acid, HNO3, turns into H plus, NO3 minus in water. Sulfuric acid turns into H plus. So just remove one hydrogen from sulfuric acid. I just have to explain here that for sulfuric acid, if you see that it becomes basically 2H plus and SO4 2 minus, that's through two stages. In stage one, sulfuric acid loses in water. It loses one hydrogen first. So another hydrogen is attached. And in stage two, it's HSO4 minus, which is bisulfate, if you remember the name, is going to lose another hydrogen and turns into SO4 2 minus, which is this guy. So this is in two stages, stage one, stage two. Because acids, they actually release their hydrogens one by one. Okay? First one hydrogen goes, and then the second one, and then the third one. The first one goes faster and more easily. The second one, it's kind of harder. And the third one, sometimes it's not even going. What is the third one? When I say third one, you can think of H3PO4 in water, phosphoric acid. So if you put phosphoric acid, it loses one hydrogen in step one, so it has H2PO4 1 minus. When you have H2PO4 1 minus in water, it's going to lose another hydrogen, which turns into HPO4 2 minus. As you can see, the negative sign actually is rising. So from 1 to now, HPO4 2 minus. In water, it releases another hydrogen, turns into PO4 3 minus. So we have 3 positive hydrogens, right, that are released in water one by one in 3 steps. The majority, 80%, are the first hydrogen, and then we have, about 15% second hydrogen, and maybe 5% they can actually do the third hydrogen. So that's why the first one is always the most. The second and third, the percentages would be less. Okay, so this is an acid. So this is a general formula for acids. So they have hydrogen because according to Arrhenius theory, acid is a substance that produces hydrogen ions, right, in water. So we have HA, A standing for anything, like A could be Cl, A could be a nitrate, A could be sulfate ions, anything. Any anion, basically. That's why we put A. A means any anion, because hydrogen itself is positive, right? So when it dissociates in water, we have H plus, so it's positive. So it needs an anion to be called an acid. So, and it's aqueous because it's in water. Even if you don't write H2O, it's still fine. Let me actually write this down for you. If you write it as HA, aqueous, without writing water, you can just show it as H plus A minus, and aqueous. So it means just like HCl in water. You see? HCl, when you say aqueous, it means it's in water. So you can say H plus, aqueous, Cl minus aqueous. You see? So HCl in water, it dissociates and it releases hydrogen. Now, there is, guys, another way of writing this, and I'm going to actually show you how, because sometimes they actually write water on the arrow, or they just leave it as aqueous. So aqueous means it is in water, right? But if in case, if you actually put water in the equation, like this one, liquid, if I just write H plus aqueous plus A minus again, this can never be balanced, right? The question is, where is oxygen? What happens is, when this guy gets dissociated, I mean, in reality, what happens? So those guys, they actually get dissociated, and this H plus is absorbed by water molecules. So from water molecule, which is like this, H2O, right, is going to receive another hydrogen, which is hydrogen ion, like that. Remember, oxygen had two lone pairs, right? There we go. One of those lone pairs can be shared with a hydrogen that does not have any electrons. So oxygen is going to share two electrons, one pair of electrons, one-sided, with hydrogen that is empty of electrons because it's H plus. So hydrogen has only one electron, and when it turns into an ion, remember, hydrogen, which when it turns into ion, it's just the nucleus. There's no electrons. It doesn't have any electrons. That's why, guys, H plus or H, because it might be attached to water, we call it H3O plus. So H plus or H3O plus is called proton also. So if you hear from someone in your chemistry lab saying that, yeah, this acid actually releases two protons, you're like, what? Two protons? What does that mean? Well, two protons means two hydrogens. Hydrogen ion. Two hydrogen ions. Or H3O. H3O plus is called hydronium ions. Hydronium. So hydronium basically is the same as hydrogen. Okay, it's a so hydronium, let me actually put it down this way. Hydronium is hydrogen ion attached to water. If you have a hydrogen ion that is attached to water molecule, we call it hydronium ion, H2O plus. So the number of hydronium ions is basically representing the number of hydrogen ions, right? Because hydronium ions, as you can see here, they have, this is hydronium ion. So they have hydrogen ions attached to them, right? Okay, so back to here. So if you see HA aqueous plus water liquid gives off hydronium, H3O plus, aqueous plus A minus, that hydronium, as we just said, is basically nothing but hydrogen. But again, if you write it this way, you have to write hydrogen ions. You can't put hydronium because there's no water in the equation. But if you put, what if you put this way, because you're writing water molecules as the reactant, and you need to balance, so it has to show up as hydronium ion on the other side. Again, which is basically hydrogen ion, same thing. So both these forms are accepted, okay? Both of them are accepted. There's no difference. Well, the second one is better because honestly, that's what's happening in reality. When you put an acid inside water, this is what the reaction is going to look like, okay? All right. So hydrogen so hydrogen is called a proton. Hydrogen is just called a proton. Hydrogen ion. So what is a proton? A proton is a hydrogen ion. A proton means a hydrogen ion because hydrogen has one electron and one proton, right? One electron, one proton. If hydrogen actually, so there we go. This is the nucleus with one proton, right? And then one electron is outside. This is hydrogen. So if hydrogen loses one electron, so this shell is gone. It does not exist anymore. Okay, so you're basically left with one proton. So that's why we actually show it as H plus. So it means one electron is gone, and only thing that is left for hydrogen is just one proton. So that's what we call it, a proton as well. Okay, so this is the definition of acids by Arrhenius. Remember, guys, we're just right now talking about Savanti Arrhenius's theory, what he basically said about acids, how he defined acids and bases. So Arrhenius said anything that releases hydrogen in water is called acid. And he said anything that releases hydroxide in water is called a base. Hydroxide ions. Like if you have sodium hydroxide in water, the ions get dissociated into sodium and hydroxide ion. So this is called a base. Okay? Potassium hydroxide, for example. When you dissolve it in water, it turns into potassium plus hydroxide minus, OH minus. So this OH minus is hydroxide ions. Okay? So according to Arrhenius' theory, acids are substances or compounds that release hydrogen in water. Hydrogen ion, sorry. Hydrogen ion. That's the correct way of saying it. Hydrogen ion in water, or hydronium ion. But hydrogen ion is the best. Hydrogen ions in water. Bases are compounds or substances that release hydroxide ions, produce hydroxide ions in water. So this is based on Arrhenius theory, okay? And this is the guy, Savanti